everyone. Welcome to the first episode of Future of Data and AI. I'm your host, Raja Iqbal. So today it is a privilege for me to host Luis Serrano as our very first guest. Luis is one of the best educators out there who has popularized generative AI and large language models. I am personally a big fan of his tutorials on transformers, attention mechanism, and embeddings, and some of the somewhat more tricky mathematical concepts. I like learning math by just visualizing it and looking at it as opposed to just sifting through the equations. And Luis actually makes it very easy for me. Well, personally, I'm an educator. I teach this topic, and I also learn from Luis. So I look up to him. So Luis, it is a pleasure and a privilege to have you. Thank you for coming over.
Thank you so much, Raja, for inviting me. It's mutual. I'm a huge fan of your work, of Data Science Dojo, the way you all teach machine learning and data science and bring it to everybody in such a comprehensive way. I really admire. So I'm very happy to be here. Thank you for having me.
Yeah. Let's get started, right? So I was looking at your LinkedIn profile and then trying to see where you're from and all of that. So tell us a little bit, right? So you're based in Toronto now. You work for Cohere at the moment, but where you originally from? Where were you born? What was it like growing up as a child?
Yeah, so I live in Toronto, and I've lived in sort of Canada and the US for a while, bouncing back and forth. But yes, I am originally from Colombia. And I grew up an only child. My mom raised me by herself, and she made a huge effort to give me all the education. That was her thing for me, and just stretching every penny to give me the best education. I'm always gonna be very, very thankful for that. And that sort of gave me the planted the seed for me always being a learner, and that's pretty much what I've been doing.
Okay.
Yeah.
I owe a lot to both my parents, but especially my mom. And someone was asking me in one of the panel discussions. So I told them my mom did very good prompt engineering for me, right? So, she put the right guardrails and all of that, right? So, and she was a disciplinarian, and I owe a lot to my mom, actually. So, I mean, do you think the same way? I mean, was she strict, very academic? I mean, how was it like growing up?
Yeah, she was definitely strict. I had I had two very strong women raising me, because it was my grandma and my mom, and they had very different personalities. My grandma was very sweet and soft. My mom was like a strong, strict person. And so it's interesting that I had sort of the two sides. But the common denominator was strength, right? Like, it was not, easy time for women. Never is, but it was much harder back then, and they had to develop this resilience. And so, growing up, I saw it. I see it much later. You analyze it back, and you see it much more. But yeah, definitely she was strict.
So are you grateful to her for not letting you slack off, right? So, because when I was growing up, I mean, I had kids in the neighborhood. They would just go and, maybe not as disciplined as my mom would make me, right? So, and then at that time it was painful, right? Say, hey, why do all the other kids get to play and I don't get to play? I mean, I used to play, but it's almost like uncontrolled, fun, right? So, and that was not okay. So, I mean, how was it for you?
Yeah, I mean, I was always kind of the shy kid, growing up very shy. So I wasn't that much into playing it, but I did. But I was kind of nerdy all my life, like being inside and playing with Legos and building stuff. Like, it was always that. I always had that side. So I was not that much trouble, as in like going outside and doing things. It was also like a city that was not so super safe in a time that was not safe. So going outside was a challenge. They would always be like, no, kind of stay close where I can see you. But yeah, I was not that much trouble that in that sense. But I did have I was a distracted kid. Like, my mind was everywhere. So like, paying attention, stuff like that. That was always like getting me to sit down and do homework was very very challenging. So I don't know how she did it.
That's wonderful. So I was looking at, I learned that you were part of the team that represented Colombia. And did I say it right? Colombia? It's
Colombia, yeah.
Right. So you represented Colombia as a high school student in 1998 and 1999, and actually won a bronze medal for Colombia in the Math Olympiad.
Yeah.
How was it like? Just tell us, how did it go? I mean, did you prepare a lot? How did it all start?
Oh, the story how it started is funny. This was the highlights. If my life had a reel of highlights, that's the first one. Being able to go to this competitions was just an amazing experience, and meeting people from all over the world, and just having that thirst to solve problems, and that it really was, and being able to travel at that age with your friends. I mean, that is to me the best experience I've had. And obviously, you travel for like a week, but you train. It's kind of like being an athlete. Like you travel for a little bit, but you're studying the whole time. It started really funny because I used to fail mathematics in high school. I used to hate math. And as a matter of fact, it was 8th grade when I was the only one that failed in my class. We were 108, and I was the only one who failed mathematics. It was failing that year. And so I hated mathematics, like, because it was just formulas and technicalities. And it was like a following instructions, right? Like they tell you what to do, and then they quiz you on how to do it. So it was like, but I didn't know I hated it because of that. I thought I hated it because I hated mathematics. Like,
and this is what I was going to ask you. Did you hate math, or did you hate the way it was taught, or you did not know what you hated? Right?
Now I know that I hated the way it was taught, but I thought I hated math. And so many people, when they say, "Oh, I hate math, I'm so bad at math," I'm like, no. You hate technicality, you hate abstraction, but you don't hate math. Math is everywhere. Math is just the way we...
And it is beautiful, right? It is just the most amazing thing once you start, right?
Yeah, it's like music, right? Like you listen to music and it's beautiful, but if I just show you a bunch of partitures and cheap music, then you just be like, well, what is it? And if that was what they showed us first, we would think it's awful, but it's beautiful. But in math, they show you the formulas first and not the thinking. So I hated mathematics. And then there was the national exam. I was lucky that I was in a school that would always do the national math exam. They would take time off. And so I thought, if I skip 2 hours of class, that's wonderful, right? Because I was an awful student in every subject, really. I just couldn't concentrate. I don't have that. Like I have ADD. I just cannot focus on anything. So I was an awful student, but at the time, you don't think, oh, there's a difficulty in learning. You just think the kid is stupid, because that's how we talked back in the time, right? So anyway, I just thought of me as a person who's just not intelligent. And then I took this exam, the national math exam, because I would skip 2 hours of class, and I would just be like, oh, I'll doodle for 2 hours. And then I go into the exam, and I think it's the math exam, which is awful for me, but there's no formulas. There's very little formulas. It was all puzzles. It was all games. And I love puzzles. I was always nerdy, but not a good student, right? Like I loved, I don't know, there were like magazines with puzzles that I would used to do, and I would play games with puzzles and like I would always love that. But it didn't occur to me that could be math. But in this exam, it was just puzzles. And so I enjoyed it. I just like, well, if I'm here for 2 hours, I might as well. And so I really enjoyed the exam. But I didn't think much of it. So I just left, and and then one day I'm walking in, and the math teacher comes in and says, oh, hello, congratulations, Luis. And I'm like, and I thought to myself, did she congratulate me because I finally passed an exam? Like, is this being sarcastic? And he was very nice. He was like, you did very well in the Olympiads. And I was like, oh, really? How did I do? And he said, well, you were first. And I thought, oh my God, I've never been first in school at anything. Mm-hmm. He said, no, you were first in the country. And I was like, in the country? How am I going to be first in the country if I'm the stupidest one in the class, right? Like, and so it turns out I was the first in the country. And then I started liking math class, but because I started seeing it differently. you know. And I did get lucky with some teachers. Like this teacher, for example, was actually one that explained it very well. When I started looking at what he did, I started liking it. But here's the highlight: that the prize for winning the Math Olympiad, if you're top something, like 30 or something, then the prize is that in the summer, in this vacation, they send you to math camp. So it doesn't sound like a prize.
Yeah, that's what I was going to ask. I mean, did you see that as a punishment at that time, right? So hey, I mean, yeah, to a math camp.
No, so I went to math camp, and it was a lot of things, because first of all, well, mathematically, like first socially was amazing, because in the school I was bullied, you know, I didn't like it, and when I went to math camp, I was with people like me, you know, so socially it was a huge thing. And when you're that age, you know, 14, 15, like social is everything, right? So to me, that was already, even if I hated the math, that was already the thing. And but here's the main thing, right? Like I walk into the first day of math camp, and it was difficult, like the challenging as hell. But they would never do what they do in school, which is that they teach you the method and then make you apply it, right? Because they don't quiz you in that. They start with a problem. So the first day we got there, and the teacher just puts a problem on the board and says, go. And I'm like, how am I going to solve that? You didn't tell me how to solve it. It's like, well, that's the point. You figure it out. And then they would give us hints, you know, say like, oh, I tried this, and they would help, and somebody would pass to the board and solve it and stuff. And to me, that made a difference in how I see education, right? Because it's not teaching us to be followers, but to figure things out. When I do that, when I teach, I never give quizzes after. I always do quizzes before. I don't go, how do you do this after I told you? No, before I tell you, how would you do this? And you get the most amazing ideas. Like I get like ideas that I sometimes better than what the standard thing was. So yeah, so that opened my mind, and then I was obsessed, and then I just continued. I skip a lot of schools for going to the Olympiads. I loved it. I would fail in school. It doesn't matter. I'm never there. Who cares? I barely passed school, but yeah, the Olympiads were just my life, and I would go there. There were 2 trainings a year, in the summer vacation and the winter vacation. It was Colombia, so it was no seasons, but it's the same. But it was in December and June, and if you kind of keep going up, and if you do well in the high levels, which that was my last 2 years of school, then you get into the team of 6 people that go represent in the IMO, in the Math Olympiad. And everybody's just obsessed to go to that thing. Like everybody wants to go. You work so hard to get there, and when you get there, then the training is super intensive. Like you train, like we had a camp who was like trained at midnight. You know, the whole day. It was you were just like an athlete. Like you were focused, and somehow I could focus on that. I could not focus on anything in school and classes, but I would hyper focus when it was about solving problems. And yeah, I mean, we did well. I mean, some countries do amazing, you know, China, India, like Russia, they're just amazing. We were like, you know, so like we did okay. But it was the most amazing experience. It shaped my way of thinking. It shaped the way I make decisions. It shaped absolutely everything. And I'm still in touch with Mary Falk, is the person who runs that Olympiad, and I'm still go visit her all the time. She's such an amazing human that did so much for me, that I'm so thankful to the Olympiads.
And you, when you won the bronze medal, so I'm sure that Russia was there, Eastern Europe. I mean, some countries from there. Right? So then they were there, Singapore, China, I'm assuming, India.
Yeah.
So South Asia. I mean, so these countries, they may have been there, right? So how was it like? I mean, winning the bronze medal for?
Yeah, no, it's amazing.
Was it the first time Colombia winning?
Well, no, I gotta clarify something. There's more medals, right? Like it's not first, second, and third. Like I wasn't third in the world. The third in the world was, you know, somewhere so China or something. There's a bunch of golds and a bunch of silvers and a bunch of bronzes, and so Colombia did get medals. We got some bronzes sometimes. We got some silvers and 1 gold back in the day. China normally gets 6 golds or 5 golds, and the top countries do very well. But yeah, to get a medal, you have to be ranked high, and I was very, very happy. Yeah, I think a lot is your math, but a lot of it is your self-esteem. And I think I I think I had the math, like I was very well trained. If I went back, I think I would go with more self-esteem, because when you come in and you know that you're not in a country doesn't do normally so well, it's kind of like in the Olympics, right? Like if you're competing against somebody who's just every time they win gold, you get intimidated, and I think that helped. Like that, I went in intimidated. Uh, I think I think we had great trainings, and in retrospect, I think if I would have had more confidence, would have been better. And I think most of the years I spent in the Olympiads, more than developing my math, was developing my confidence, and I think that happened to a lot of us. Like we talk about it when I see with my friends who went in the same teams. We're like, yeah, I think we had a pretty good level, and I think we should have been more confident. But it did develop my confidence a lot. Like it just kept, it did a lot for it. Yeah.
Yeah, that's great. And I'm assuming that going from someone who hated math to someone who, as for the rest of his life, being passionate about math, do you think winning that within country competition or Olympiad,
Yeah.
was that the turning point for you?
Well, that was the turning point. Yeah. Yeah, I think that helped me throughout all my life. I've always had difficulties. I'm always gonna have them, like in many things. It never was like easy after that, but it did give me a good start, and then it made me take the best decision I've taken, which is to study mathematics. At the time I think it was the time like late 90s, and in Colombia, like I think the mentality was like you have to do something that gives you money. And so everybody was like, well, if you know math, you should study engineering, you should study economics, you should study something like business that gives you money. And I'm like, I just thinking like, if I'm awful at school, I'm going to be awful at these things, right? I can only do math. It's the only thing I can do. It's the only, like literally, I have to figure out a career based on math, which at the time it was not easy, not obvious. Right now, you can think of it as data science. So you can study math and do well, but at the time it didn't exist. So it was not, but I couldn't do any other thing. And so it was just a decision I took, and then I never knew what I was going to do in my life. I just knew that I enjoyed it. So, just going through undergrad and then grad school, the decision was always easy because I just wanted to do a little more math for a little longer.
Mm-hmm.
It turned out to be a great decision, but at the time, the only thing I could do.
And you mentioned your grad school, like going to a master's and a PhD in math. So did you always have this in mind that you're going to be a mathematician, or you thought that, yeah, I will learn it and I will figure out maybe, so what was going on? Or you were just smelling the roses along and just
really
doing what you were enjoying?
I was smelling the roses. I only took decisions on the next step. When I went into math, I just knew it was the thing I liked. That's it. And I thought I'll figure something out on the way. When I was finishing math, I started understanding what the academic career is. And so the academic career, and the PhD, right? Like the academic career is you do a master's, sometimes in some places you go straight to PhD. But the fact is, you do a PhD, and then you do postdoc, and then you become a professor, and then you do math for the rest of your life. And that's what all my friends were doing in math. There are very few who would switch to other places, but the majority was just like being a professor. So then I thought, okay, I'm going to be a math professor. And so I took the next step that was a master's, and the next step that was a PhD, and the next step that was a postdoc. I never questioned, should I do this? I was more concerned of where can I go? Like what can I do to get into the best possible place, or what can I do? Like that was the only concern. Where do I go for the next step? But it was never, should I do the next step or not? Because it was just, the way.
Yeah. And then when you finished your PhD, your first job was at Google as a machine learning engineer?
Yes.
And you were working on personalization and video recommendations.
Yeah.
Right.
Yeah.
So please go ahead.
Right.
So it looks like the teaching was not the top priority at the moment. What was going on in your mind? Because post Google, everything is teaching. Most of it is teaching, right? So,
Yeah.
But prior to Google, between your PhD and now, right? So there was this brief period. What was going on?
I in retrospect, I would love to explain it as a story of how I planned things and how I was brave to make switches. At the time, it was just a struggle, Mathematics. I liked mathematics, but I didn't think of it in the way I wasn't like everybody else. My friends were very brilliant, like high level. They were thinking high level, like they would understand things very quickly. They would do research. It was always in high level. They would speak in formula stuff. I always had difficulty with formulas, and I was lagging behind a little bit. In classes, I would always take a little longer to understand. I would always have to bring everything down. Mathematics is very levels of abstraction. Like you learn the basics, and then there's lemmas on top, and then you make theorems. And at this level, people talk, and it sounds like philosophy. Like it sounds just, and I can never understand that. I always have to bring it down, right? And so that took me forever. So for research, for example, I was slower. Like I was a slower researcher than my peers. I always found that teaching was easy. Like I would, my talks, people would go, like my classes were full. Teaching was always came up easy, but the research didn't. And I didn't, somehow the passion for the research wasn't there. Like I still did it, and I had a great group and stuff, but I was always the one who was trying to understand it, to explain it. So I was the explainer. I would give the talk. But it was just, research wasn't, it wasn't, I started questioning. It really wasn't my thing. And if you, like a year before, because everything you do in academics is you apply a year ahead or something to a position. Like everything's not like tech, but you apply it 2 days before. So I started thinking that maybe I wanted to do something else, and I didn't know what. I just knew I wanted to survive, and the chances of getting a job as a professor that I wanted, at a place that I wanted, and that I was going to do well in my life were not that high. And so I started just looking at other things and just learn how to program. I knew a little bit, but I wasn't really that much. So I took some courses in programming and machine learning, and I started liking it. And, at the same time as I was applying for professorships, I was applying for other things. And, exactly as I predicted, that I didn't get any professor position. And so I started thinking, okay, I now I really need to do something else. And I started interviewing in different industries. So I tried in finance or consulting, things that my friends went when they left academia. It was common to leave academia because it's a bottleneck. Like there's all these students, there's all these postdocs, and there's all these professors, and not everybody gets a job. And I was one of them. So I had to figure it out. And funny enough, people think I went to Google because the world was my oyster and I just picked Google. No, it was actually the only place. Like I wasn't, I knew a lot of math, but a lot of industries was not, I'd get interviews, but it was clear that I wasn't for them and they weren't for me. Somehow, and a job as a programmer, I didn't know how much how to program. So like wasn't that clear. But a friend told me who had left academia for Google, like he called me and said, hey, you should come to Google. And I'm like, well, I don't know how to program that well. And he said, no, neither do I. The interview is math. And indeed, I went to the interview, and there was a bunch of math questions, like a bunch of the stuff I liked, the puzzles I liked to do, like the stuff I was doing from the Olympiads, like that helped me. So I went in and did really well in the interview. And somehow I wouldn't have done well if it was like another data science company where they need someone to do the stuff immediately. Google could take a bet on somebody because they had taken a lot of bets on academics that move in. They don't know programming that well, but if they can, if you can push through a PhD, you can push through a lot of things. And so I ended up at Google, and that's why I had those 2 years of not teaching, of programming. I just wanted to have a job that I could eat. I didn't really think of where my career was going. And it seemed like I would open doors, and it did it. It opened doors, yeah. But I struggle at Google, because I'm not a programmer, yeah. So I can elaborate more.
I can relate to so many things that you're doing, right? And sometimes I tell people, right? So, when they say, "Hey, did you?" Because I also first, if someone asks me, I tell them I'm an educator first before anything else, right? Machine learning, everything else, right? So entrepreneurship, all of that, it comes later, but at heart, I'm an educator, right? So I enjoy explaining things. I can relate to so many things actually that you mentioned. Right after finishing my PhD, getting a good academic position, it is hard, right? So you can get a small, college, or, you can get it, right? But getting into a good school as a professor, as a tenure track, it is very hard. And when I tell them, I mean, Microsoft was the only job I had at that time. Being an international student, I took it, right? But I can relate to so many things, right? So when I came in at Microsoft, I was, as you say, because I would call them kids, right? So it took me 6 years after my bachelor's to get my PhD, right? So, and these folks who had been programming for six years already, I was behind, right? So and I was behind. Not that I was not smart. I worked hard, right? So, but then then I joined Bing, and Bing, I was doing a lot of experimentation, and then it became mathematical. I started teaching within Bing. People, machine learning was up and coming. So many things. I mean, one thing led to another. So I can totally. I mean, at least I'm one of the people in this world who will totally relate to you, how your journey actually unfolded, right? So that's amazing, right? So I get that.
Yeah, I think for sure.
And then you moved to Udacity right after.
Yes. So people are like, "Oh, that's so brave that you left Google. Why did you leave Google?" And I never tell the story.
I get that too.
Yeah. So I'm curious of how it changed for you. I'll tell you how it was for me. Like I didn't think about it. It was not a brave decision. I was struggling. I was fired from Google. Like I'm not a programmer. Like I can program, but I'm very slow. And I like to think everything just like it happened in math. Like my struggles in math were because I can't think in high level and I have to bring everything to the basics. And with code, it was the same thing. So I was like trying to understand the models and how they work. And I was like, oh, you recommend was like a neural network. How does a neural network work? And I'll be obsessed on that. And of course, I had to write code fast and get things done. And so I was just slow. Like I couldn't do it, And so, but I learned a lot. And after 2 years, it was clear. And so it was, my boss was very kind. We were had a good relationship, and she said, "No, you can if you get these things done, then you're okay. But if you don't, you have to go. But I would, if I were you, I would use this time to find something else." And so I thought, I was very depressed because first of all, I failed in in research is what I wanted, and then in programming, which is in 2 years I had 2 big failures. After a life of many, great things I had before. So I was very depressed, but I had to go back and say, what do I want? And I thought, okay, I'm just thinking survival. I'm not thinking about thriving. I'm thinking, how do I survive? And I thought maybe if I go as a programmer to another place, it's not the level of the place that's the problem here. Like, I'm not going to do it. So I need to see what am I good at? And whatever it is, I need to go to that. And it turns out that, when I was in academia, the research was so-so, but the teaching was amazing. And when I was at Google, it turns out that, I was teaching on the weekends, like in webinars, and I was teaching, like if people came to visit, like I would be the one giving the talk and stuff like that. So I thought I just have to teach, like that's what I have to do, wherever it is. So I thought maybe I'll go teach high school, maybe I'll go as a teacher, like as an instructor at university or something. And one day I was taking courses online because I was taking a lot of courses online, and then Udacity pops up, and it was just like lectures by people who worked in the industry, and they were good teachers, And I thought, oh, I could do this. Like I could teach online stuff. I'm always doing that. Like I'm always explaining stuff all the time. And so I just applied, and actually I was in Silicon Valley, so I was across the street. So I crossed the street to the interview, and the interview was explain anything you want. And so since I always try to understand these algorithms, I thought, okay, well, maybe let me explain how a neural network works. And I used to think about them with rabbits that, had big ears. And if you have big ears, you're here in this spectrum here and small. And then there was the lines that would decide if, I made the explanation that I knew that I used to understand that would slow me down because I had to explain myself everything with cartoonish scenarios. And I gave them that, and they were like, oh my God, it's exactly what we need. And then I started Udacity, and it was the first time that I absolutely clicked with a job, because what I had was exactly what they needed was exactly what I had. And so it was the most productive period of my life. We were building, and it was when like AI was starting to get super popular, when discriminative AI and neural networks and all this stuff. And so I was learning the stuff and teaching it immediately with a team of educators that were amazing. And we created so much stuff, like so many courses. It was just the first time that I really was like in the perfect harmony with my environment. And after that, I've always been teaching. I've been moving around, but it's always gravitated towards teaching. Like my jobs are always like in a company, the teacher. And I do my own thing too with the YouTube channel and things like that.
That is wonderful.
I'm curious.
Please go ahead. Yeah.
Your transition now. How did you go? When did you say I'm a teacher? When did you decide like this is what I'm gonna do?
Actually, I was the teacher all along, right? So because after my undergrad, I wanted to teach. Then I got into my PhD program. I got my undergrad in Pakistan, right? So right after I was applying for grad school as well, got into a PhD program right after my undergrad, fully funded. I said, okay, I will leave, right? So, but even right after my undergrad, I wanted to teach, right? So I told you how I ended up at Microsoft, and within Microsoft, there were opportunities. We used to have a boot camp for all the new Bing employees. So, and Bing, I joined at a time where there was a joke, right? So they are hiring people so they can have more users for Bing, right? So in those early days, right? So, it's early days. I joined Bing, and then this teaching the bug was already there, right? So always there. So I would teach, and then actually when I left Microsoft, I did not leave Microsoft for teaching. Data Science Dojo did not happen at least until maybe another year after I started Data Science Dojo. So I started something else. And then I was doing Data Science Dojo. It was a small meetup group in Seattle. I was teaching for free. The same thing. I was just doing it for fun on the side, really with no compensation in mind. The other startup was not going anywhere. And then I had this idea, hey, why don't I start charging people for this? And then rest is history. Right after that, when we launched, I think the timing was right. We started around 2014, right? So, and the machine learning everyone was trying to figure out. So we created this curriculum. I still think it is one of for our data science bootcamp, it is one of the best curriculums because, having done all of that at Microsoft, so we were the only bootcamp at that time that was teaching A/B testing, for instance, right? Okay. So many bootcamps were out there because, design of experiments, all of that, we would teach it because I knew that it is an important thing in the toolkit of a data scientist. But after that, one thing leads to another, right? So I just said goodbye to the other startup, and then my other startup, right? So it didn't go anywhere. But this one started, and then now.
Awesome. Well, I'm glad you did it. I did it.
But I enjoy it, right? So when people going back to it, right? So sometimes, and I've seen many people, right? So a lot of professionals, they define their worth based on which company they work for, or what title do they have, or what seniority, what ladder level that they have. Are they L7 or L6? We very often live someone else's life. We are there is this, and so sometimes, when you pick something that you love and you can make a living out of it, that's the best situation to be in, because the paycheck is just a bonus. You're enjoying it, right? So that, and I can see this happening in your case.
Yeah, for me, like I heard once that when there's a few like sentences that are like describing that, like cliches, but they are nice. Like one is like, if you like what you do, you're not gonna work a day of your life. It doesn't feel like work, just what you're doing. And is that when you like something, you don't look for reasons to do it. You look for excuses, right? Like I just have to do it, and it's my thing. And yeah, I think that sort of standardization of our way of thinking, it starts with education. They make us well in standard stuff. and be followers and be trying to they try to mold us into the perfect student that then morphs into the perfect professional that has all these check marks. And I don't know, maybe there's someone that for whom that works perfectly, but I think the majority doesn't, and I'm glad that I was able to fit that mold, because then you're forced to look for your own thing, right? Like to look for what's your passion, and you gotta align two things, I think you gotta align what do you like to do for fun, like a Sudoku or a crossword puzzle or running outside, whatever, and what you want for the world, right? Like what is it that the purpose that you have for humanity. And I'm sure that it aligns for you in the same way as it aligns for me, right? Like education is a place where you can bring opportunities to other and level the playing field, and that's sort of the purpose. And then I just like to teach, whether it's useful or not, I like to do it, right? So yeah, thinking of alignment.
So I noticed that you also work for a company in quantum computing.
Yeah.
So what was did you go back to industry once again in a more of a product development type role, or what was your role at that company?
Yeah, that was very interesting. And I just, when I had two big career changes in my life and they somehow paid off, even though there were difficulties, I kind of get confident of career changes are good. And so I was at Apple educating and teaching at the Central Apple University. I was really enjoying it because I was giving boot camps and internal consulting. But a very good friend of mine called Alejandro Perdomo, who's a top quantum scientist, turns out that him and I were talked a lot, and I would pick his brain in quantum computing the entire time. I was always interested. I didn't know what it was. And one day I decided to send him a message, and I said, I have a great idea. You and I write a quantum computing book, okay? I don't know about quantum computing, but I know how to explain stuff. So you explain it to me, and I write the book. And he said, yeah, that works, but I have a counter offer. Come work with me. And I thought my first thought was I don't know any quantum computing, but then I also didn't know programming when I went to Google's and I learned there. So I thought, okay. So it turns out that the job was researcher. It was a researcher in quantum computing and quantum machine learning. And so I knew the machine learning, and a bunch of people knew the quantum computing and were learning the machine learning. And I came in knowing the machine learning and learning quantum computing. So it was amazing. Learning from this guy was just amazing because he knows so much. And to me, it was like doing a master's. I didn't think, a lot of people, even inside the company, said, well, that this may not work, right? And I was like, okay. That's like doing a master's and getting paid for it, right? And it indeed was, and I did some work, it was research. Again, my thing is not research, but I was enjoying it, learning a lot. And we did get some interesting results. And it pushed me towards working in generative learning, because quantum is very much involved in, actually, I believe, and I got this from from Alejandro, that quantum is more of a generative thing than classical, and I think that would be the advances. So I got more into generative learning, and I really enjoyed working on that. I learned so much, and it was a good bet,
And can you explain the simple for a layperson what is quantum computing? For many of us might not actually know what it is.
Yeah. So actually, the thing is, computers have bits, right? It's a 1 or a 0, and it's a 1 or it's a 0. That's it, right? Well, when quantum computers have qubits, which is anything between 0 and 1. Actually, the simplest analogy is like a switch that's on or off, and this is like a slider that you can put it on or off, or like in romantic, and like in the middle, and you can put it in anywhere. So imagine a number and anything between 0 and 1, and there's more, because it's actually imagine a spherical switch, okay? A light switch that's spherical. And if I'm in the North Pole, then I'm turned fully on. And if I'm in the South Pole, then the light is fully off. And if I'm anywhere in the equator, it's half-half. And as high as I am, the higher I am, the higher, the more light, the more 1 is, and the lower you are, the more 0 is. And it's a full sphere. However, it's in this is the understanding that quantum computing has. Nobody really knows why or if it is, but it's the only thing that matches with the observations, which is that if you don't look at it, then it's somewhere. The special point is anywhere in the sphere. But the moment you look at it, it either goes up or goes down to the North Pole or the South Pole. And if it's if it's higher, it's more likely to go up. If it's in the North Pole, it stays in the North Pole. If it's in the South Pole, it stays in the South Pole. If it's in the equator, it goes 50-50. And if it's lower, it's more likely to go down, Just like, if you were going to put two magnets and one of them pulls the little special point. So, but here's what's interesting. I think here's where the thing clicks. And I'm going to be kind of high level here. But imagine that you're in a computer and you want to do an operation to the number 1 and to the number 0. I want to square it or add 1 or something. I need to do an operation to the 1 and then the operation to the 0. I need to do two things. But if here I have a qubit that's in between and I do the operation to that thing, I'm doing the operation to both at the same time, the 0 state and the 1 state. So I need to do one operation here while I'm doing two here. Now imagine this doing two more. Oh, I'm getting the zoom. If I do this, I get the.
Oh, so this is your setting on Zoom?
I think I have that setting. I gotta watch out. I can't do too many great story things because I get images. But anyway, as I was saying, on the classical land, you have to do two operations to the 0 and to the 1. Whereas in the quantum world, I do one operation to the qubit in between. So that's 2 to 1. It's not that much. But imagine having many qubits here, and here I have qubits that are entangled, which is something else completely different. And I do less operations when I have to do more operations here. And it's exponential, right? So here I have 2 to the n, and here 1 to the n, which is less. Of course, when I observe it, a lot of stuff gets lost. So that's the catch, right? But if you do it in a smart way, then you can save a lot of operations by doing things here correctly and measuring them correctly. And so imagine things that are exponentially hard here are linear here. Obviously, there's a lot of complications, but that's the principle. So you can do things like, for example, factoring numbers, right? Like, the cryptography is based on if you can factor any number. So for example, like I can say 3 times 5 is 15. That's easy for a computer. And that's also easy if I have huge numbers. Multiplying is easy. But if I say 15 is 3 times 5, that's factoring, which is much harder. Because if a computer is given millions of digits, a number with millions of digits, it's not able to factor. It takes millions of years. And that's a basis of cryptography, right? Like, this, right? Like, so it's basic cryptography that if I were to factor numbers, I could break most cryptography. And quantum computers have an algorithm, Shor's algorithm, that makes it really much faster to factor by using this principle, and others. So anyway, it's really interesting. I loved learning about it. I had to relearn a lot of linear algebra that I thought I knew and I didn't understand so deeply. So it's a lot of fun.
Mm-hmm. And do you think that quantum computing can have any implications in terms of generative AI?
Well, conceptually I do, because here's the thing. I feel like classical computers are supervised learning machines, right? Because you put the input, an image, and the output, which is yes if or no if it's a dog or not. Like it's completely deterministic, right? Quantum computers are not good at that. But when it comes to generative learning, classical computers are great, as we've seen, but they always have some difficulty, which is generating random numbers, right? Like anything you do, a GAN or something, you have to generate a random number and feed it through the thing, or sampling is difficult, because at the end of the day, what's the simplest generative learning problem? The simplest generative learning problem is flip a coin. Like generate a number between 0, which is 0 or 1. Generate a bit randomly. That's the simplest generative model in existence, because it generates the basic unit of information. And computers cannot do that. Like a classical computer cannot generate a random number. It can pretend, right? It can do a pseudo-random number, but they're not random. If I were to recreate the conditions of the universe and press the same button, I get the same number, Whereas quantum computer, it's the complete opposite. Cannot control it. It gives you random stuff even if you don't want to. And so the simplest generative model, which is generating a random number, is the hello world of a quantum computer. The first thing you learn in quantum computing is generate one random number, and they're random. Like this is truly randomness. And so if you make that bigger, then the generative models, the quantum generative models, don't have the difficulties that the classical generative models have, which is, the sampling. You don't know if you generate the right number to input the thing. You don't have that problem here. And so if you train a circuit in the same way as you train a neural network, you train a quantum circuit to start throwing out the stuff that looks like your data. We actually empirically saw results that it was better. Like experimentally, we compared it to an RBM or to an autoencoder or to a GAN even. And this one of the same size, obviously, because you have to do apples to apples. A circuit of a small size actually did better than its classical counterparts in the experiments we did. We don't have, a theoretical proof that it's better, but we ran the same thing with the same number of qubits as the bits here, and it just had a better luck. I'll give you an example. Let's say, it generalized better. For example, like if I give you bit strings of length 4, and I always coincidentally gives you ones with 2 ones, right? I say 1 1 0 0. No, with an even number of ones. 0 0 0 0, 0 1 0 1, 1 1 1 1, like things with an even number of ones. If I feed you that data, the model learns to generate that data. However, the quantum one kind of learned the rule. It started learning that it was an even number of ones, and it started generating stuff that was not in the data set, far from the data set, that satisfied the rule. Whereas the classical always kind of stayed close to the data. It would generate things that was close to the data. The other one would come up with something crazy that was not close to being in the data set, but somehow satisfied the rule that I gave the data set. So we saw that, and it was encouraging. Obviously we need bigger quantum computers. There's no question about that, because the classical computers are humongous. So that's a huge, it may or may not happen. Like technologically, it may or may not happen. But I thought that at least conceptually, it was nice that it was better, that it showed better signs at generating things. Yeah. On the other hand, it was not good at supervised. Some people have done great in supervising quantum computing, but then you see difficulties because they're not deterministic. I could say 1 + 1, and it says, well, maybe it's 2, but maybe it's 2 million with a small probability, So found that supervised learning was a classical computer thing, and general learning was a quantum computer thing in principle. Yeah.
That's great. I mean, thanks for the explanation here. You ended up in Cohere toward the end of 2022, right? So
Yeah.
How did that happen? You were already in Canada back then, right? So you were in Toronto.
I was in Canada. Yeah, I was so at Zapata, I was kind of I was a researcher, but I always gravitated towards teaching. So I was working in giving courses and blog posts and talks and stuff like that. And so Jay Alamar called me, which is, you must know him. He's a great educator, a friend of mine. And he said, hey, we're building a course in LLMs, and I don't know if you're free, but with
And Jay was a friend before Cohere?
Yes, we worked at Udacity together.
I see.
And I loved his teaching. It's amazing.
He's amazing. Yes.
Oh my God.
Without a doubt. Yeah.
I learned he teaches me the machine learning. So he called me and so I took it seriously because, and then I interviewed, and it turns out that the other 2 people in the team that was building the course were people I was a fan of already. There was Sandra Kulik, who's a YouTuber and wrote a book in LLMs. And there was Mio Ammer, who also wrote a great book in machine learning that I had actually been in touch with before. So I was like, oh my God, I want to work in this team. So it just made sense. And it started, the boom of LLMs was kind of starting. Actually a little before. ChatGPT came a month after. So it was, in retrospect, I mean, I could say it was a great visionary move, but it wasn't. I just wanted to be there. But
in hindsight, it is, right? So
it happened a month before the boom of LLMs. I joined an LLM company. And my job is to build the course. So we built this course called LLM University.
And one of the best, right? By the way, so I picked up a lot of concepts that I was not clear on from Cohere. Cohere is one of the best documentations out there on any
Thank you.
template.
I'm so happy to hear. Yeah, I enjoyed it. Really.
Yes, I mean I can imagine, right? So I mean because it's almost like you're still working in industry, you're still connected to product, but still you're more in a teaching type role, right? So I think that's the best position to be in.
I'm always gonna be teaching, and I love that I can talk to experts and ask them stuff. Like I just have I can go and ask a million questions to somebody, and I love it. So I always might feel like I'm doing grad school and learning stuff, and getting paid for it. So I like it.
Yeah, that's a good situation to be in, actually.
Yeah.
So let's move on to perhaps more of the current the AI, how AI has evolved. So reflecting on the evolution of AI, can you paint a picture of how it has transformed over the years to the present day, and how do you see it or envision it changing in maybe shorter term or longer term? What do you think is going to be changing? And let's talk more about technology first, and then maybe we can talk about the society angle in a moment.
Yeah, so I'll answer the technology one, and then we'll get to the society, which also opens up a whole new topic. Well, technology, it's been wonderful because I got into AI like maybe 10 years ago, when the boom of discriminated AI, right? Like the one that answers questions, yes or no questions or numbers. Is this image a cat or not? Is this sentence happy or not? Is the email spam or not? Like it just answers questions that we can answer, but faster and sometimes more accurately. So that was wonderful. And at the time, everybody was, it was common thing to say, well, I think the next step is generative stuff. Like there was very small generative things, right? Like when you say, like, I would create a very simple looking image, or it spit out some sentence that maybe made little sense, but it looked like it was wording things. And so you could see it coming. GANs were big, RBMs, obviously, when the large language models came in, and the stable diffusion that builds images. That was a huge step. That will actually surprise me when I started playing with language models, and I was like, whoa, this talks to me. That was big. So after, it's always hard to tell, but I think after discriminative machine learning, then there was generative machine learning, and I feel like a big step will be multimodality. Like I feel like now language models take text and return text. Image models return images or read images. Same thing with video and stuff. But like humans, we don't operate like that. Like if I tell you something I know, I don't remember if I learn it through text or through an image or through a video or somebody was talking or I saw something. Like it's all the same to us, right? And then when it comes out, it's the same thing. Like I could explain a concept, but I could also draw an image and I could also write it down, and it's no difference. But for models, it is different. Like either you do it with a language model or you do it with an image model. So I think joining all those three, all those many, will be a big step, I think, when we start. And I saw it a little bit in Gemini, I think is by Google. I've seen a bit of that. And I think that's sort of the next step. Another step would be like, I think when you start joining it with things that move like robots or something, I think that will be a big step. But there's also another sort of conceptual thing that I find interesting. And it's kind of like, I remember that before neural networks, it was a lot, like things were pretty clever. Like algorithms were pretty clever. They were like probabilistic or something, where you would study the problem and solve it in a clever mathematical way. And then neural networks came in and just kind of like solved everything easily. And it felt like cheating, right? Like it's like, if you put everything in a super high dimensional world and learn some stuff with the neural network, just so many parameters, it solves it better than the super clever Bayesian probabilistic method you had. And that was kind of disappointing. And I find that sometimes that may continue happening, right? Like it may be like, I don't know, the other day I put into a large language model a little data set of like linear regression, and just from words it solved it, right? Like it was like, oh, this, like that kind of things. And I wonder if like language models are gonna start like maybe just out of knowing a lot of text, be able to solve stuff that's not necessarily requiring text, but they're just so hyper parameterized that the solution is somewhere in that space. So it may be disappointing in terms of the cleverness of the solutions, but I think it'll give us better solutions. And so also, I guess this may go into society, but also like the fact that coding is now easier, right? Like now it's more prompting, you know, like the previous generation had to do assembly and cards, punch cards and stuff. I don't know how to do any of that. I do Python. The next generation is gonna know English, right? Like, or language, and be able to code like that. And I find that exciting, because I think that can bring many more people into AI, not just the coders, but anybody who knows anything about any problem to solve is going to be able to use technology, not just the programmer. So I find that part pretty exciting, the fact that it's going to be more universal to everybody.
Yeah. And do you see as we increase, the models start getting bigger, more parameters and more, bigger context windows, and all that, more compute being available, more data being pushed in. Where do you see this headed? I mean, what do you think is the most exciting part of it? I mean, do you think a bigger model is necessarily a better model? Because there is a lot of effort happening, and and I would not name any company here, right? So company X will come in and say, hey, we have a bigger model and it has more parameters and more token limits, right? So where do you think this is going? That's the first part. I mean, do you think a bigger model is better necessarily? And the next part is, how do you think this whole, I would call it the race to a bigger or better model, do you think, is that what you see the future is going to be?
Yeah, that's a very good question. No, I definitely don't think a bigger model is a better model, but I do think that sometimes you need to sort of go bigger and then cut the things you don't need. So I think it's necessary to, obviously a bigger model doing the same thing works a little better than a smaller model, but then eventually you bring things down, because a bigger model can definitely overfit or do crazy things. So I think getting bigger is one step in the process of getting smarter. But I do, yeah, it's hard to tell again, but I think we'll find, I think embeddings are the clue to everything. And I think we're starting to get better and better embeddings. And for anybody who doesn't know, embedding is basically you take an image and take into a bunch of numbers, or a sentence and take into a bunch of numbers, because computers do numbers, right? So a voice or a video and take into a bunch of numbers. So the more you can have that translation, the better. And so if you find a translation that is sort of agnostic to the type of information, that sends the image of a dog to this very close numbers to the word dog and to the sentence dog, right? The sound, something like that, I think, would make everything better. So I think working embeddings, you cannot save efforts in embedding. They don't have to be bigger. You don't need to have million numbers per word. Like, I think if I find a really good embedding, they have to be at least thousands. You cannot summarize data in less space than the data lives. But I think we'll be able to find really good ones, and then things become easier, right? Because, for example, 10 years ago, classification of language was difficult, right? Like, if you want to make a spam classifier, I would need to give you a million spam messages and a million non-spam messages, or at least tens of thousands, right? For somebody to build a good enough model. Now, 4 messages, you know what I mean? Because the embeddings are so good that if I take a few messages and I send them to the right numbers, then the math problem becomes much simpler, because before the numbers weren't so good. So to tell between spam and non-spam, I needed a really complicated region that would say, here you're spam, here you're not spam. But now the embeddings are so good that I may have something very simple where all the spam messages get sent here and all the non-spam messages get sent. Just draw this line, right? So I think better embeddings just make everything easier.
And do you think that we will converge towards more toward smaller models, domain specific, small, we have started to see this term appearing, like small language models as opposed to large language models, right? So clever play on words, because they are still pretty big. But we get the idea, right? So do you think that that's where we are converging? I've seen one of the companies, Symbiotic, they actually, one of the partners for our bootcamp, they actually work on this conversational AI, which is, the model is called Nebula, right? So, and they claim that is purely for in a support and a conversational scenario, and it's a smaller model, but a very domain-specific model. And then similarly, maybe healthcare, financial. Right? So do you see that as a viable direction, that is going to be the future?
I mean, I have seen, for example, embeddings get a little smaller. Optimizing for search, for example, you can go from a few thousand to a few hundred, and they do better. So I think
because of possibly the curse of dimensionality, right? So you're not too sparse, and now the concepts are maybe closer to each other.
Like maybe you live in 4,000 dimensions, but it really is 700 dimensional, but it's flat, right? Like if I have if I live in the three-dimensional space, but I'm mostly in a plane, then I'm really in 2 dimensions. So a lot of data is really it's flatter than we think, and so a lot of advanced techniques can bring stuff into 2 dimensions down, and then you lose a little bit of data, but you gain a lot in simplicity and power of computation and stuff like that. So I do think, and I think this is done correctly. There's an approach of making everything bigger, but also an approach of when it's bigger, let's make it smaller and try to not lose any performance or very little. And I think that's the right way. Like I think that will continue, and I don't think things will be that. I don't think the gains are going to be that things are going to be bigger and bigger. I think they're just going to get more clever. As I said, data is high dimensional. Data is complicated, and we cannot go down. And if we're trying to have models that think like us, I think our brain has a lot of parameters, so it's hard to bring that down to very few if you want to fit basically all of humans' rational thinking into a neural network. Is gonna be big, right? But I hope it's controlled big.
Okay. And perhaps let's actually do this, right? So what I'm going to ask you is going to be at the intersection of society and technology.
Okay.
Talking about guardrails, right? So, so I know you are an educator, right? And I know Khan Academy, most notably, they adopted this in the learning and edtech space. And as more and more companies, they start acquiring or adopting generative AI and large language models as an instructional tool, do you see any risk there for, really any risk in adopting LLMs, not just for education in general? Let's start with the general industry. So anyone who knows how these things work, they have reasons to be concerned, right? So from any reason to be, the reasons could be from anywhere from enterprise data security all the way to, wrong information getting in wrong hands, to kids getting exposed to information that they should not be, propaganda. How do you see all of this?
Yeah, I mean, everything has risks, and we've seen it with AI, right? Because AI, the only thing it can do is propagate what we do, right? Like take us and make more of that, right? And as a society,
any technology, that's true with any technology, starting from nuclear technology to internet, right? So if you look at this, that's true with any technology, any groundbreaking technology.
Yeah, fire. I mean, you can use it to cook, or you can use it to, destroying something, right? Like, and everything has unintended consequences, right? Like, I mean, even go way back, like agriculture, like it, made life more comfortable. We didn't have to go around hunting all the time, but it also like made things, started things like property and wars and things like that. And it, we were eating things that we were not prepared for, like that kind of things, like any advancement in society, like has its risk, whether they're like obvious or completely unintended. And the internet has that, now we have access to all the information, but somehow we didn't get that much smarter. Like it's a lot of misinformation. There's a lot of manipulation, and everything, So I think obviously this has its risks, and we've seen in data science that like it basically it propagates our personality, and it propagates our mistakes as a society, which are society's racist, society's sexist, society's elitist. It's a lot of awful things that are in the data, whether like not in hidden intrinsically in a way that it's really hard to detach, and that goes in the models. So that there's no escaping that, and I think we always have to be very, very careful of that. There's always going to be guardrail. They're never going to be enough. I think the only thing that we always have to keep in mind is that these things are tools. Like fire is a tool, we need to use it, but at the end of the day, we can't let it control us, right? Like we can't let it take decisions. I would use language models as a way to help me with a lot of things. But the moment I start taking life decisions based on a language model, then I think that's a problem, right? I can elaborate on that, but let's look at education. I think looking at it in the positive side, I think there's a lot to gain, because education has a lot of flaws. Like we sit in a classroom when we're kids, and we're competing for grades. Why do we have to compete for grades? Why can't everybody do well? We're working individually. Why can't we work as a group? At the end of the day, we survived millions of years working as a group. We've been individualistic for not very long, So those kind of things are wrong with education, and I think that they can be fixed with. I use ChatGPT and large language models, Cohere and Tropic, like all these ones. I use them to learn. Like I go into a language model and I start prompting it. Like my videos, I make them like that now. Like I start asking it things. Okay, how to explain this to me? But now explain a different way. Now with this little example, help me understand this. Okay, let's focus on this little part of the formula. And you can do that. And for other things, like, about society, I go, okay, tell me about this. And I start analyzing, right? Like, oh, don't you think that this led to that? And it helps, and as long as I use it as a tool, and I check my sources, because many times it lies to me. Like I've had problems with some of my videos that I put something that the language model told me and it wasn't true. And so I think that's a great tool for education. I think that if kids or anybody, like adults, anybody can go in it, ask it things and have it like an expert that you can talk to. It's wonderful. Obviously you can, talking to an expert is better, but like many times, that resource is limited, whereas you can be talking to these language models and learning to be critical, because what I was saying about, education teaches you to be obedient. It teaches you to follow rules, to do things as you were told. Never to think critically, never question the teacher in grade school or high school. Nobody ever goes, hey, I think you're wrong. This, we're meant to follow orders. And so I think we can get, I think large language models can be used as a tutor in a very, very productive way. I've been using it myself. And so I'm very optimistic about that. And then other things, right? Like, I mean, education is something that is very restricted. Like traditional education, you have to live in a place that happens to be in a good location for a particular school. Some people don't have that opportunity. You have to be in a certain socioeconomic place where you can study. Many people don't have that access. Chronologically, like if I'm 60 and I want to start learning something new, society doesn't really play well with that. All those barriers can be taken down with tech education, with AI. So I'm very, very positive about that. Cautiously positive, but I am very positive.
But as a high school science teacher or a math teacher, would you encourage using Chat GPT or Bard or one of these applications?
You have to. I mean, it's kind of like you can't stop kids from using a calculator to do math. Like if I give a kid 100 sums and additions and subtractions, I can't expect them not to use a calculator at home, right? So what I can do is I make them do harder problems that they, even with the calculator, they will still need to think. And I think it's the same thing with language models, right? Like I can't stop students from not using ChatGPT or any of these models, right? And at the end of the day, they're going to use them at work in whatever they do. So I may as well just make them use them well. So for example, you can ask for an essay, but you could also ask for a 500-page book, and they need to use ChatGPT for that, right? Like, so they would use it. Like, so I think you kind of, it has to be like a philosophy of if you can't beat them, join them, because at the end of the day, these things are better. And at the end of the day, there's a fear that we're gonna lose a lot of skills. Yes, that maybe our grandkids will not know how to write essays, but you know what? You and I don't know how to make fire by rubbing rocks or hunt a buffalo. You know what I mean? So like,
I love this analogy though. Right? So, but because I see this as a natural progression when Google and the search engine era, Yahoo. Actually, I actually love Yahoo as a company. For some discussion for some other time, right? So I feel sorry that we lost Yahoo because they are the ones who actually brought search mainstream, right? Google happened much later. Yeah. But when search happened and Google was actually one of the more popular search engine when we saw the search engine picking up, we had the same concern, right? So, and, all the devs, they use Stack Overflow, whether they want to admit or not, everyone uses it, right? So, so I think these are tools, just like you gave this example, we don't make fire, ourselves anymore, right? So we have other means to do it.
Yep.
Do you think that educators, high school or elementary school teachers, they also have to be somewhat upskilled in these technologies? Because they cannot, when I look at it, right? So if I'm an elementary school teacher, when I give this assignment, hey, write an essay or a poem about this, or, something along those lines, it will take them less than a minute, right? So do you think fundamentally the way we approach education or critical thinking, that these tools are going to be put, or those approaches have to be put in context of the development that is happening in these tools? Yeah. And the educators, they have to learn these tools to create assignments that create critical thinkers, as opposed to, and who use these tools efficiently, by the way.
Yeah. And I'm glad that we're having to do that, right? Like that we're forced to change some things that needed to be changed, right? Like these definitely needed to be changed. And it's not a full upscaling. Like it's not like, the history teacher has to learn how to program. No, like they still have to know their thing. But I think these language models are easy to use. And I think it's not about being technically savvy, but it's about being creative. Like if you're a history teacher and you use a language model or you make the students use language model to, understand something in history, to analyze things, to throw ideas at the computer and have them develop them back. I think that's very useful, and anything, any field I think can benefit from this. In education, and I encourage them. I encourage teachers to use it for their own benefit. It helps them as well, and for the benefit of the students.
And what is the most exciting application, or something that is closer to your heart, that you see will result as it will either start happening, or it will be better than it has been before? There is this pre-LLM or pre-generative AI era, and any application, any area of impact in society, really any area in our life, it could be education, healthcare, industry, traffic, just anything. Do you have anything that you can think of where you think, wow, I mean, life is going to be so much better. As humans, we are going to be so much better as a result of LLMs. Have you thought about this?
I mean, concretely, like all things I'm excited about. I think medicine. I think any like car, like transportation. A lot of things can be made better. Obviously, you and I are educators, and I always think in education. So I always think, the fact that you can now learn by building things, the fact that you can interact, because interaction is the most important thing. I don't want to just be sitting down listening to information. So that's what excites me more. But what really, really excites me of large language models, and I think that I want to be like, I'm optimistic, and if I'm full optimistic, because I have my pessimistic side, which is we'll end ourselves. But my optimistic side says we will be able to use language models to have a sort of like a second cognitive revolution. I think I look at the early humans, right? The early humans, they were just mostly physical creatures, right? Like the one that would do best is the strongest one, with the smart, like with the best arms and strongest arms and legs and something, and they use their brain very, very little for like little things, like should I hunt that animal or that one? But then they started, the cognitive revolution. They started using the brain more they went from like thinking about things that existed, like a tree or an animal or something, to think about things that didn't exist, like money, for example, which is an agreement, right? Or like a certain mythology, like a story of why we exist, or the, gods, things like that. Creating stories, and that was a huge step, right? So because we stopped using, like the brain started being more the useful thing, and now we're at a point that we still have physical labors, many jobs, but the way to succeed more is using the brain more. So like we became from physical beings to rational beings through the use of machines and everything. Every time there's a machine that does more for us, we become more rational, and our jobs are more thinking. Now I'm thinking that that's going to be gone too, because now language models can do a lot of our thinking. So we went from physical to rational, because the machines could do our physical stuff. Now machines can do our rational stuff. Where do we go, right? Do we become obsolete? Are we done? Like, are we as good as a machine and that's it? And I believe that that's not the case. And I think we have to look at what is it that we can do that machines can't. And if we do it properly, then we'll be able to transcend to a higher level, where the first level is physical stuff, the second level is rational thinking, and then there's a third level, which to me, it involves anything regarding empathy, anything regarding emotional intelligence, anything regarding spirituality, things like intuition, And it sounds silly, right? Because these are basically taking decisions that don't require AI. And AI really, if you think about it, AI takes very good decisions, but they're all maximizing some variable, right? Either profit or the number of patients that are okay, or the number of females that I caught in spam. It's always maximizing or maximizing some variable. There are a lot of decisions that we take that don't require maximizing or minimizing some variable. And they're normally tied to empathy, to caring about others, to thinking as a group, to thinking, that I can't explain with a variable. And I think those are what makes us human. And it sounds silly, right? If I were to tell you in 100, 1,000 years or something, we're not going to be thinking that much rationally, but we're going to be meditating and coming up with the ideas, the decisions that we have to take by intuition. Like, that sounds silly, but it also sounded silly to the cavemen if I tell them that in the 1,000 years or thousands of years, they're not going to be using their body so much. They're going to be using only their brain, when they only use their brain for very few things. Right now, we only use our intuition and our emotional intelligence for very few things. But I think that that's what's going to be the next level for us. If we do it properly, we're going to transcend that. We're not going to be rational thinking humans. We're going to be much more spiritual. So that's what I'm hoping that this helps speed up.
Spiritual and empathetic.
Empathetic,
And
that much.
and do you think humans are by nature? Humans do have empathy by design. Do you think they are like that?
We are. I think we're born with that, and it gets domesticated out of us in childhood. We turn into individualistic beings. We turn selfish. We turn materialistic. But I think we're born without all those things, And I think we need to, I think regardless of tech or no tech, we need to transcend that and decolonize our mind from all those things, But I think we didn't survive being individualistic for millions of years. We survived by working as a group and by not thinking of you and me as different people. We are the same. We just, happen to look like we're separated, but we're not. And I think that what would save society is that if we get rid of that, get rid of the ego, and you start thinking as a group. And I think I'm hoping that this step this will be a step in that direction, because at least we won't be occupied the entire time with rational things, and we have to pretty much whatever the language model can do is what we have to start doing, right? So I have hopes.
And you're hopeful about, right? So this is going to be for the better for us, right? So whatever the way things are headed, despite seeing some of the negative, like deep fakes, for instance, right? So, or maybe, propaganda and all of that. You think that we will be better off as a society as a result of, all the developments that are happening?
Well, yes and no. I think the developments help, but I think it's up to us. And I look back and I think it's never just been technology. And I have that sort of disagreement with many of my tech friends, because people think we're one technology development away from being a utopic society where everyone's happy and we sing kumbaya. I doubt it, because in the past it hasn't happened, like when the steam engine came in the, 1700s, nobody said, let's free the slaves. Nobody said, oh yeah, we can do work. Let's free the slaves. Nobody thought that. If anything, it made it worse, because it made more trade and more work was needed. If anything, it made it worse. And so many people think, well, when we have ChatGPT,
and easier to bring in slaves, right? So
and you could transport more. Yeah, it made it worse. And so now people think, well, now that ChatGPT does our work, then we can just relax. Well, nobody's gonna say that. Nobody said, ooh, language models can do our work. Now finally we can free the wage workers. No, we're gonna figure out a way to work ourselves until we die, because we've done that with every single technology development. Every time a new technology comes in, we never say, ooh, make it better, make it better. We always take the other way. So it's up to us to, I think it's up to us to use these technologies correctly. I think they help, but I think, it's the big changes in society have happened not because technology, but because of a strong change of thinking, a revolution. We get rid of an idea that we had before. Monarchy came from we thought the kings had divine right, and when that ended, we stopped thinking about that. With the French Revolution and things like that. So I think we need to decolonize our minds of many paradigms that we have existing, and that's more up to us. I think technology can help us find things, and I think, I'm excited about technological breakthroughs, but I think we need to use them properly.
So we are, I hear someone who's cautiously optimistic, right? So you are, because you're a technologist, you see what could go wrong, but at the same time, I see someone who wants to see things being better in society, right? So, So do you have any? When I look at it, right? So there has to be. Not everyone is going to be. Hey, I'm a nice human being. I am not going to do this, right? So then the societies, they have to evolve, right? So if I don't have a stop sign or a traffic light, likely I will just zoom through, right? So I'm not going to stop, right? So, So speaking of that, I mean, what kind of ethical and social considerations, or possibly some legal framework, some lawmaking, do you think along those lines that the society has to evolve in terms of the laws? Because laws, how do you handle many of these things, right? So, just as an example, I'm not taking one side or the other, right? So New York Times sues OpenAI, right? So how is it different from a human actually going and learning and becoming an expert, right? I read the newspaper, and then we had this unfortunate situation when Taylor Swift, her pictures, I mean, they were doctored and they were all over the internet, right? How do you protect people, individuals? And this has happened in a high school somewhere in New York as well, right? So how do you protect individuals from this kind of behavior? What kind of lawmaking? What kind of ethical, social considerations? Maybe parents, they need to talk to their children about this, right? So, just like they would talk to their children about drugs, right? So, and then, is it going to be part of our upbringing then? How do you see that? I mean, it's maybe the question is a bit ambiguous. I'm looking at the society. How does it shape us?
Yeah, it's very complicated, I mean, it's like any technology, fire, right? Like, how do we stop everybody from setting everything on fire? Like, we have regulations, but that doesn't stop me, like, so we have the regulations, we have the ways to stop it, the fires, everything. But, at the end of the day, it's not unstoppable. Like, we can't stop people from setting things on fire, and never will. Best we can do is a combination, as I said, a combination of regulations, a combination of ways to act when these regulations are broken, and mostly just teach ourselves to not set things on fire, like, I think that's the most one, so I think for AI is the same thing, you can't stop it. Like, regulations are always late. It's very hard to stop. So I don't know, like, you can't go back in time. Like, these deepfake, like, things generate images that look a lot, that steal the work of the artist. You can't go back with that. Like, you can't untrain the model, and you can't trace it. So you can say, well, this looks a lot like this, it's plagiarism or not. Like, this kind of stuff is very ambiguous, and it's very hard to detect and hard to stop. I would say some things we need to do, which is we can't trust voice or video anymore. Just like I can't trust an email. Like, if you get an email signed by my name that says please wire this money, you won't do it because it's an email. Anybody could have typed it. Well, now if you get a video of me with my voice saying, hey, Raja, please forward this money, you won't do it because you can't trust this kind of stuff. So we'll have to figure out ways around it. But I think humans have to not not trust this. I feel like, we're teaching a course of responsible AI right now, and it's very challenging. And we have sort of 3 levels of responsibility. And the best that each one can do is, like, I mean, which one should do the best? It's kind of like an analogy of like electricity, right? Like there's the electric plant, there's the person who builds the oven that uses electricity, and there's the user who has a kitchen and builds and uses it. Each one has to be as responsible as possible. So the electricity company has to make sure that it's steady and that it, doesn't have spikes and everything. The one who builds the oven has to make sure that it doesn't have a short circuit or something. And the one who uses has to make sure that you don't use it in the wrong way that create a fire. And each one has its own responsibility. So we have the creators of the language models, Cohere, OpenAI, everybody, Google. They have to be as responsible as possible, and not like have to make sure that these models are as unbiased as you can and as safe as you can, which is not easy. Then the people who build the apps have to be careful as well to make sure they're not, you're not propagating all horrible things. And then the users as well. So it's a responsibility of all of us, but it is hard to regulate, and it will always be. But what I think is that it kind of, I don't know, it kind of reveals cracks in society that need to be fixed regardless. I'll give you an example. This is my opinion. When like an image model plagiarizes the work of an artist, which is an awful thing, and it's hard to detect, as I said, and artists are thinking, you're ruining my career, you're ruining things, but it can't be stopped. So when I think of that, I think, okay, we have a problem, can't be solved. Is it that it was already a problem before? And so this happened to me. Like I one day put something into a language model, and it was a mathematical question, and it answered in a very mathematical procedure. And I knew that some part of it was work of someone I knew. And so I when I talked to that person one day, I said, look, I took a screenshot and I said, this is exactly your thinking. Like, this is exactly your stuff. And it didn't credit you. Like, it didn't, it was like your theorem, but it didn't say. And he said, no, it's okay. Like, I like that my knowledge gets propagated, right? So I'm thinking, why does this person not get concerned that got plagiarized, but the artist does? And then the answer was, because the mathematician has tenure and a stable life and doesn't have to sell theorems for a living. Like, it doesn't be like, look, I discovered a theorem every time.
That's a very interesting viewpoint. Yeah,
I get 10 cents, right? So this person has a stable life, and so they can get concerned of propagating knowledge and not having to worry about getting credit. Of course, they get credit in like papers and stuff like that, but they didn't have to worry about getting plagiarized by a language model. On the other hand, the artist does get worried, because that's a day of eating that goes away if they don't manage to sell that image. So is language models screwing artists, or are we screwing artists? You know what I mean? Like, have we been awful to artists beforehand by forcing them to have to sell their images to be able to survive? And could we do better there? Because if we could do better there, and the artist was okay being able to live without having to sell their images, they wouldn't care. Maybe maybe they wouldn't care if something looks a lot like their art. They would probably be saying, oh my God, this is immortalizing me. You know what I mean? I may be wrong. Maybe an artist comes in and says, no, Luis, you're wrong. Maybe I don't discount that possibility. But I think that a lot of things that AI is bringing is cracks in our society that already exist. So we need to be better with that, So, I think a lot of AI problems cannot be solved with AI, but they need to go deeper in society and fix the original problem.
Yeah, I love that. I love that. I mean, it is basically exposing the cracks that already exist in society. So, do you think the legislation and regulatory bodies, they're ready for all of this? Because at the end of the day, right? So when we invented cars, right? So we had to come up with traffic lights and stop signs, right? So, we could not say that, yeah, people rode horses earlier and, they self-governed, right? So you have to have some sort of regulations. I mean, what are your thoughts? I mean, which country, which regions do you think are actually doing something, and which regions, which countries are oblivious? And of course, I'm talking about where you see not every country in the world, but countries that are more, more ahead in technology, right? So where there is more technology adoption.
That's a good question. I don't know of different countries doing different things. Like, I feel like a lot of them are making efforts. Like, there's definitely efforts from the tech side. There's efforts from the government side. And I think, yeah, I mean, an industry cannot regulate itself because it's a conflict of interest, right?
Yeah, I mean, and many companies, I mean, the shareholders actually, or the board actually gets to decide, what direction to take, right? So, and so it's a different loss function. Let me put it there. It's a different optimized. I mean, they are optimized on a completely different equation, as opposed to not necessarily best interest of humanity all the time.
Yeah, exactly. So if you regulate yourself, it's gonna happen what's happened with every industry that has regulated itself, which is chaos. So I think they're definitely the external external forces regulating this. But it's a difficult problem because things change all the time. I mean, law goes much slower. It has to, have to think about things much carefully. Whereas tech is kind of like, does it work? Ship, launch. It's a different speed of things. So it's not easy. I think, I think regulations are absolutely needed. They can only go so far. And I think it's like security, right? Like, you can put a police at every corner, but why are cities safer than others? And the reason is because in some places there's less social inequality. If you go to a place where nobody needs to rob, they won't rob. If you go to a place where people are starving, there will be insecurity. Comes from there, and no amount of police will be able to stop that. It may make things worse, And so I think, if we have a society where you're not in a necessity to do something bad, that's the only way to stop things. So again, revealing cracks in our society. You know what I mean? But yeah, it's a hard problem. Like, I don't know the solution.
Yeah, it is a hard problem. I completely agree with you. I mean, I'm asking you difficult questions, I guess, right? So,
no, I like them.
But I'm trying to figure this out, right? So I'm trying to understand all of this. As you learn more about these technologies, as you learn more about what they are capable of, I mean, these are the questions that naturally come to your mind as a citizen of this world, right? So you try to understand how this is going to impact you and the future generations. So do you foresee more of a symbiotic relationship between humans and AI? So we have traditionally talked a lot about human-computer interaction, right? So now, do you see some kind of, do you think machines will surpass human intelligence? And if they do, or if they don't, I mean, so whichever it is, how do you see this kind of, coexistence? How do you see it evolving?
Yeah, no, absolutely. I think they will surpass human intelligence as we know it, like rational intelligence. Yes, like that same way that they're faster than us, right? They're stronger than us, and they're more precise than us. They already succeeded the human body. They were just missing the brain, and now they are succeeding the brain. So anything that's rational about us, any decision that we take rationally and with data, anything data driven or anything like that, I think they'll be able to do it better. And that doesn't mean that we're done. And that's where it comes again, that we have a higher level that's not rational. And I think if we manage to do a symbiotic relationship, it will be like what we have with the current machines, right? Which is that, I mean, a car runs faster than me. Can't pretend it doesn't, right? But I use it. to go faster, right? I don't race against it. I'd be silly to race against the car, right? But I drive it and it gets me somewhere farther. And in the same way, yeah, I think if we manage to develop our mind that is not rational, like at our higher level emotional intelligence and intuition, if we develop that much more than what we have it right now, we'll be able to drive these cars, these models, these machine learning models, to get us to much farther places. I will be able to do things, unimaginable things. I'm being super optimistic in this answer, but we'll be able to do great things.
We have no choice, right? So we have to remain optimistic, right? So we don't have a choice.
Yeah, and so we'll be taking the high level decisions that are not based on some numbers, but that are based on much higher things, and use the machines to the language models to do the mundane, rational things that our mind does right now, in the same way that now I'm using a bunch of machines to do the mundane things that my body would have had to do back in the day, So, yeah.
Okay. So, so you have a lot of fans out there, right? So even within my team, my younger data scientists, so they were absolutely excited when they heard Luis is going to be teaching at the boot camp, and some of them actually attended the session and they loved it, right? So for any aspiring data scientists in general, what would be, or when I say data scientist, I still consider this a broader term, right? So it includes LLM, right? So traditionally we have used this term for, classic machine learning and analytics, but assume now LLMs are also part of this tool set. So what are some of the, what would be your advice for them to, how can they excel at what they do? How can they be really good at what they do?
Yeah, no, great question, and thank you, and say hi to them. I'm very happy to. I was very happy to give a talk at Data Science Dojo, and it was a great crowd. So yeah, thank you. To the well, I think one thing I did, which I was forced to, but some people are not, is that I had to follow what I liked. I couldn't do anything else, right? Some people are able to do things they don't like. But even then, you should still try to follow what you like. It's like the gradient should be your joy. So like, we always kind of know, like we never sometimes have other ideas and paradigms and stuff, but we always kind of know what we like. Like if you ask anybody, what would you do if there was no, if everybody made the same salary and there was job security, whatever you do, what would you do? And for me, it was teaching, but I never knew it concretely. And everybody has that. So just try to find it, try to explore and always be true to yourself, and don't worry about job title and things like that. And obviously that may be a tone deaf thing to say because we have to survive, and sometimes some jobs just keep, more money than others. But to the extent that is possible, to the extent that you can explore, never stop exploring. That's one. And in order to learn stuff, I feel like I have a way to learn things that is, I imagine that is like soccer, for example. Let's say somebody wants to learn soccer and they don't know anything. What do? Do you give them a book of soccer rules and techniques and say, read it and then come back? No. You give them a ball and say, go, kick it, run with it, explore, experiment, get some friends and play and kick it between you and each other, and then enjoy it, and then later I can tell you what the rules are, and then and then I can tell you more, and then if you become an expert, like if you become really good at it, then I give you a book and I say, look, these are techniques or these are the rules, but the book is the last step, not the first one. And that drives me crazy that when people ask experts, how can I get into data science? And the first thing they do is, you have to know how to program, you have to know linear algebra, you have to know calculus, you have to know blah, 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 blah. You give them a list of things. No, that's not, like, to me, that's not. I have good work for people. But to me, that's backwards. And so what I say, you want to learn it, you just go on a language model and start prompting it and start asking it how it works and start asking it stuff. Soon you'll realize what it can do and what it can't and how to hack it and that's prompt engineering. That's like which may be the next thing, I don't know, but it may be the next data scientist. And then when you say, okay, well, now I want to do one more step. I want to fine-tune a model to answer questions about soccer. Okay, so then you go and read something and learn how to plug in some data to like you're basically learning in the practical way. And then later, if you're so into it, then I'll be like, okay, here, let me teach you some linear algebra. But that's later, or programming or something. Like play with it, play with it, enjoy it the way you would learn a sport. And I find that that's how I try to learn things, and that's how it works. And it's more fun.
Yeah, have fun, right? So at the end of the day,
always look for that, and look for the things that matter to you, right? Like if for data scientists, I say take a data set of something you like, maybe something of a mission that you have in life, or maybe some sport you enjoy, some movies you enjoy. Like take a data set of that and play with it, plot it, see what relations there are. Are there two groups of data, one here, one here? Well, what are they? Like ask questions about that, but with your fun involved, like with your hobbies or whatever you like. And that's the way that it doesn't feel like learning. It feels like you're just exploring stuff. And then the data science becomes the second thing because you're just enjoying about something you like already, So I think that's to me that the way to learn. And when I teach, I try to have that. I try to have everybody do their own thing and have it as personalized as possible. So, because everybody's different, and we all have something different to offer. There's no reason to put ourselves in a mold and deny to the world all we can give it, right?
Yeah. So let's switch gears and shift gears and go back to the personal side of you, right? So. Sure. So I follow you on LinkedIn, and I see almost like an activist, someone who cares deeply about society, humanity. Doesn't matter whether they are from Colombia or they are, from Luis's family. So they could be any people anywhere, and you're pretty vocal about that. So where did you get this from? And do you think that as a technologist, should I be worried about what's happening elsewhere, or should I be only worried about, hey, I want to be the best at what I do, and I can't change things, right?
That's a very, very strong. That's a very strong side of me, and it's always been. I mean, when you grow up, as in an unequal society, like sometimes it's hard to see injustice, but when you see it, you can't unsee it, right? And the more you see it, when you see imperialism and you see the genocides that are happening right now, I think we're technologists, but at the end, we're human first, and I think not being enraged when we see a genocide like what's happening, like the many that are happening right now, it's impossible, I find it impossible. And I tried for a while to not post stuff, especially on LinkedIn, which is a different flavor than, say, Twitter or Instagram or something. So I kept it for a while, but this has escalated so much. And we're seeing it in real time. This is not something that's happening behind in the news or something. This is something that we're actually seeing it being recorded with phones, and it's very difficult to see it. It's very difficult to see that it's happening and not be able to do very much about it. And I wonder a lot what technology, what we can do. At the very least, I think with education we can teach people to be more critical, because I think that's the problem that we have, right? Like we are sort of domesticated to be followers in our school. We just think of the teachers as figure that we never question, so that we don't question the news, we don't question the corporations, we don't question governments. And so we have some paradigms that we just never question. And I think there's a very strong thing here that people have, which is frankly that we are taught that some people, that to see some people as less humans than other. If this kind of genocide happens in say in a developed country in Europe or something, everybody gets concerned, which they should.
All of us should, right? So all of us, right?
Whenever something happens, we should all get concerned. But we are selective, right? Some places it happens and we go, oh my God, humans dying. And other places, it happens and nobody blinks an eye. If it happens in Palestine, nobody blinks an eye. If it happens in Africa, nobody blinks an eye. Middle East, so many places, just people have less sensitivity. And I think it's just that inherent idea that some people are considered less humans than others, and that's not true. I think anyone that gets massacred or gets tortured or anything, I feel it like if it was, my brother or sister, my mom, and that's what we should feel. We are a human race, I think we should all feel it. And I think we all feel it internally, but we have so many layers upon layers of colonization in our mind, or domestication, that we refuse to, that we just it doesn't get to the surface, and when I think of why I'm being vocal, and some people have been wonderful, the Paul Bigger and people have done a lot more vocal than me, and have actually risked more than I have. I just think that, what are you, when you look at this in 40, 50 years, what's it going to be, right? Like, obviously, history always figures it out much later. We know slavery was bad. We know the Holocaust was bad. We know, apartheid was bad. We know segregation was bad. We know genocides that happen in Africa and Asia. We know they're bad. But at the moment, they are controversial, right? At the moment when apartheid was happening, there was controversy. Like, people were saying it's good. Some were saying it's bad. Now we all know it's bad, So in the future, we're all going to know. And the question is, what do we do about it? And were we at least vocal about it? And I think I'll regret not having been vocal about it. And I think it helps. I think people sharing, this is something new. It's the first time that we all kind of have a voice. And yes, it sometimes gets, the algorithms get quieted and stuff. But I think this is a time when we all have a voice, and we should use it. And I'm conscious that I have a little bit of privilege there, right? Because some people write to me and they're more junior and they say, I wanna be vocal, but I can't because my career is in danger. And I understand. And if I was in their position, maybe I'd be. Or some people are more important than me, and they have actually, like, people underneath whose careers depend on them, and they can't lose funding and they can't lose support, and they also can't be vocal, So I'm in this kind of sweet spot, and I feel like I have to, and there's probably a lot more that I can do, and a lot more that we can do. I've been involved in some groups and things like that. But yeah, I mean, it's difficult to witness. It's difficult to feel,
Do you think it is because of our lack of critical thinking ability, or do you think humans are inherently good? It is just that they don't have the information, or they are unable to process the information that is at their disposal?
I think so. I think we're born good. I like to think that. I think this society makes us individualistic because it's easier to control a group of millions of people that are individual and playing for themselves and for their interest, and having different stratifications where these ones have more privilege than these ones, and so they have to protect it, and putting people against each other. I think it's not natural. I think we are born without knowing we're different. if we're I like the ants or the bees or something, where they are just a group and they work as a group, as a collective consciousness. They don't really think, oh, I'm an ant and you're an ant, but I'm gonna try to get the best. No, they work collectively. I think we are that when we're born, but that love for others, and that gets quickly domesticated out of us by making us compete for artificially scarce resources like grades and things like that, and by making us, like, pitting us against each other, and making success an individual thing as opposed to a group thing, makes us like that, and then we're easier to manipulate, because it just feels like, somebody who's getting oppressed is not me, so why should I care?
And perhaps dehumanization as well, right? So you sort of you present the other kind as not civilized enough or not human enough. They are.
Yeah. And that's how they got away with the genocide of the indigenous people and the Americans, and in Oceania and in Asia and in Africa. Like, that's how you get away with genocide, by putting the other group as savages, when many times they're way more wise. Like, the Eastern cultures are so much wiser, and indigenous are so wise. I've been having, now that I come back to Colombia, I have the opportunity to meet the indigenous and talk and learn more about their culture, and they're way ahead of us in terms of in terms of group thinking, and in terms of everything. So I think I definitely, I think this sort of way of making the others look like they're savage is an awful thing, but it's what allows for atrocities to happen, and for people to be apathetic about it, right? Because at the end of the day, is apathy what allows all these atrocities to happen.
And empathy, the irony is that a lot of us, we keep talking about empathy in all the HBR articles, and then internally within the corporate environment, we are taught about this empathy, right? And teamwork. And somehow, as humanity, right? So as we zoom out of this, we forget about this, that these principles actually also apply as humans.
Yeah, we're learned to have, like, in a small group, right? Like in a group of our team or our company, like, try to work as a group, but never across all humanity. I think we come up with I think even question the nuclear family, for example. Like, it's obviously nice. The nuclear family is a nice concept, but at the end of the day, we're tribal. Like, we're meant to be in bigger groups and care all about each other, right? Like, when you ideally, we would, if you want to control people, you put them as individuals. What's obviously, individuals can reproduce, so we have to go let them pair. And that's the most one can do. So we have, like, sort of tiny units of tiny, and the smaller the unit, the easier it is to control. But at the end of the day, I think there are some small groups where you can where you see empathy happen, but it should be much. We should be able to have empathy for every human being and for every living being, because let's not talk about how we treat the animals or the planet. That's a large story.
And you're optimistic about the decades and the centuries to come as human?
I hope so. I mean, I think I'm optimistic. As I said, either we can go either direction. Either we annihilate ourselves, or we figure out how to live in peace and how to live in harmony. So we have the power now to annihilate ourselves completely. So it could go either way. I'm hoping it goes the way of all figuring this out and advancing as a society. We'll see. But I'm optimistic.
Yeah, I mean, we don't have any other option, right? So
pretty much
we have to remain optimistic.
Yeah.
So, Luis, I'm absolutely enjoying the conversation, but I think I mean, all good things, they have to come to an end, right? So maybe I will just start wrapping up. So I will throw some rapid fire questions at you. So given your background as a mathematician,
All right.
where you have been, so based on your background, I created these rapid fire questions, and you have to answer very quickly and maybe try to rationalize a little bit as well, right?
Okay.
So one word answer: calculus or algebra.
Algebra. I'm more of a discrete person than like a tiny deltas continuous person. So yeah, algebra.
Okay. Pi or Euler's number?
Ooh, I'm more of an Euler's number, kind of underrated. Yeah,
Is that
but it gets all the attention. Yeah.
okay? Yeah, and why is that?
I think I like E is kind of the number that multiplies most by adding the least. You know what I mean? Like, for example, if I want numbers to add to 20, and I want to have the biggest product, I can have like 19 times 1 plus times 1, which is 19, but I can have 10 times 10, which is 100. And the best I can do is 3, 3, 3, 3, 3, right? Because it's the closest to E. So the closer you are to E, the more you multiply by adding the least. For example, E to the X is always bigger than X to the E. E is that sweet spot. So that's one of the reasons I like E.
Okay, that's wonderful. So
don't get me wrong. Yeah, pi is good.
yeah, because I mean, pi is also, I mean, a mysterious number. So I mean, that's why I put you in a tough spot here, right? So it was a difficult spot.
It's a tough spot. Yeah. It's like, which kid do you like the most? You know?
Yeah. Bayes theorem or Euler's identity?
Ooh, I love Bayes theorem, but you can't beat Euler's identity. It's just, I mean, Bayes theorem is cool because we use it without knowing to make all our decisions, right? Like we have our idea of what things are, and then we get more information, so we change the probabilities in our head. So Bayes theorem is pretty close second, but you cannot beat Euler's identity. It's the most beautiful equation in math, like e to the I pi plus 1 equals 0, or minus I pi. Sorry, woof. One of those.
Okay.
I think it's e to the I pi plus 1 equals 0, right?
Yeah. RAG or fine tuning?
Go with RAG, but you need both. Fine tuning is like putting your model in college, so it learns more stuff. But then RAG is like giving your model a book to answer questions or Google search. I find that RAG is the ultimate thing that can end like hallucination. So I'm gonna go with that. But fine tuning, you absolutely need.
Okay. You have lived both in Toronto and San Francisco, right?
Yeah.
Which one?
Toronto. San Francisco's cool, but expensive. And Toronto's too. Find more diverse in Toronto.
You like the cold there?
Not the cold. No. Toronto.
That's the only downside, I guess.
A year and the other. Yeah, San Francisco has beautiful weather.
Absolutely.
Love San Francisco, but I'm going to go with Toronto.
Okay. And forgive me for the pronunciation for the next that I'm saying. So, and correct me if I'm wrong here, right? So, Bandeja Paisa or Ajiaco?
Ajiaco. I'm from Bogota, so ajiaco is the plate in Bogota. It's a soup with potato and chicken, which kind of good for when it's cold. Bogota's kind of cold, not really, but it's in a mountain. Bandeja paisa is in the Medellin plate. I love Medellin, but I'm from Bogota, and I'm going to go for the ajiaco. Yeah.
I was looking at Bandeja Paisa. Is it like paella in Spain? Is it something similar? Because the recipe that I saw, it's similar rice and, sausages and all of that.
It's like a platter with everything. It's intended to like you have it once a day and then go work the fields the entire day. So it's got plantain, rice, ground beef, pork, like crunchy pork, beef, an egg, avocado. I'm missing half of the ingredients. An arepa, it's like a corn thing. I mean, if you have one, you're in a food coma for 3 days. I like it. Yeah. But I hear.
Okay, that's great. So, what is the most beautiful mathematical equation?
I already said Euler's identity, so Euler's identity. But actually, I'm gonna go with another a less known Euler fact. Vertices minus edges plus faces equals. I think that one's pretty cool. So if I have a square, for example, what do I have? 4 edges, 4 vertices, and 2 faces because it's the inner outer. So 4 minus 4 plus 2 is 2, right? And actually, if you're in the sphere, it's 2. Like in the plane, it's a huge sphere, but torus is different. If you're in a place with holes, it's different. So it's B minus E plus F equals something different with the genus, with the holes of the number of holes that you have in your surface. But that one is pretty cool. Yeah.
And what is the most underrated or underappreciated mathematical concept?
Whoa. Yeah, that's a good question. I think a bunch. I mean, I think one that is less obvious is this. Like you can have, for example, I can make a polygon of as many sides as I want. I can have a triangle or a square with 4 sides or a pentagon or a 17-gon and a 59-gon, and it's very easy. But a polyhedron, I can only have a few of them, right? I can only have a tetrahedron with 4 faces, a cube with 6 faces, an octahedron, a dodecahedron, or a icosahedron with 20, 12, 24, 3, 4, 6, 8, 12, 20. And why can't I have a polyhedron of any number of sides that is regular? And believe it or not, the answer is not with areas or lengths of things or angles. It actually comes from the V minus E plus F equals 2 equation. It's a matter of you can't count edges and pieces and points in the correct way unless you are in one of these few cases. So that's underrated. I think I don't know, like maybe that would be one. Fractals I also like. I mean, I think the fact that we have dimensions, right? Like an edge is dimension 1, plane is dimension 2, a cube is dimension 3. Fractals can have any dimension, like logarithm of something. I think that's pretty cool. I think those two. Yeah.
Okay. Yeah, favorite mathematician?
Oh, I have 2. Galois, which is tremendously underrated. He was a genius, died at 21 in a duel. He was a huge revolutionary. And died at 21, and he would have done a lot more. Math would be different if he had lived longer. But he's the one who answered, those old mathematical questions of like the Greeks had, if you can trisect an angle. Like you can bisect an angle with square and compass, cut it in 2, but trisecting it is hard. It's impossible to do it with string. Or finding a square with the same area as a circle, or finding a cube that is twice as volumetric, as big volume as the other cube. The Greeks pondered with those questions many years ago, and it was like Galois in 1800 that developed the math that you could use to solve those problems, and it had nothing to do. It was Galois fields and groups, and come up with the most beautiful proof that you cannot do those. So yeah, Galois was amazing. And the other one, actually, it's closer to my heart because it's Hypatia of Alexandria. And I'm a huge fan because she was more of a popularizer. Like she does what I like to do, which is take the stuff that exists and understand it better. And so, like, I'm a huge fan because she broke many barriers, and so Hypatia would be my those two. I think are my favorite mathematicians.
Okay, and I promise this is the last one, right? So, favorite machine learning or AI textbook?
I'm biased. I like learning. Grokking Machine Learning. That's a very biased answer, but
and this is with your coworker, your peers from Cohere, right?
No, that's mine. Yeah. So I mean, I'm sorry for the biased answer, but I like it. I have a hard time understanding machine learning books. They always go to the formulas immediate, and it's hard. But I'm gonna give you a list, because actually Jay Alamar's book is coming out pretty soon on LLMs. That one's really good. And my other 2 teammates have great books too. Sandra Kublik has a book on GPT, And Mior has a book where Elmer has a book where he explains machine learning in like images and stuff. It's a PDF. You should take a look. It's it's about like you can like it's all with images, like explaining machine learning, but like it's all visual. Really helps someone like me that needs to learn with visuals. So yeah, those I really like.
Okay. So Luis, we'll have to close it now. I know you took the time out on a weekend. So thank you so much. It was a privilege to have you at our first episode. Really enjoyed the conversation.
Thank you. I really enjoyed the conversation too. That's wonderful. And thank you for the work you do. And I'm a big fan. So thanks for having me. It's been a pleasure.
Thank you so much, Luis.
Thank you.